This essentially is okay. All of this has come together in the last couple of years, and now we're making a push now to try to bring about some change in this region. The other thing that's sort of been encouraging for me is the initiatives that the borough and West Goshen Township have done to actually eliminate plastic bags and single-use plastic straws and other things like that in the last couple of years. I would have said 5 years ago that this sort of thing really was never going to happen in this area, but it has happened. And so I went into this sort of encouraged, thinking that this might be a good thing. So I'm actually going to start off today by showing you a video from the International Dark Sky Association, sort of introducing the topic of light pollution and what to do about it. It'll sort of be, in a way, kind of a summary of my talk, and it'll get us right into things. Okay, so let's just dive right in.
We live on the surface of a planet, spinning on its axis once every 24 hours. Its rhythms of day and night are embedded in the biological makeup of all.
For some reason, the video is lagging.
We live on the surface of a planet, spinning on its axis once every 24 hours. Its rhythms of day and night are embedded in the biological makeup of all life. During the day, we bathe in the glow of the sun. As night approaches, darkness takes over. It's a time to rest, to rejuvenate, to marvel at the beauty of the night. And night are sun. As night approaches, darkness takes over. It's a time to rest, to rejuvenate, to marvel at the beauty of the night. Until just over a century ago, our night skies were very dark. Now, even the wilderness is invaded by light. Our cities glow at night. Buildings are lit up. Unshielded lights blind us as we travel along our streets and roads. All these artificial lights overpower the darkness. The waste of energy is obvious, even from space. Much of that yellow glare the astronauts see comes from streetlights. They produce most of the light pollution on the planet. The glare is scattered by the atmosphere, creating sky glows over the landscape. We are losing the dark of night at the speed of light. Light pollution threatens the health of every living thing on Earth. Lights at night disrupt plant growth. Unshielded lights contribute to the deaths of countless land and sea animals each year. Migrating birds crash into illuminated buildings. Newly hatched sea turtles mistake the glow of electric lights for the shimmer of the ocean's surface. Bright lights at night also directly affect humans. Drivers and pedestrians temporarily blinded by poorly designed lights have suffered tragic accidents. Light pollution poses a silent threat to our health. Exposure to light at night disrupts the circadian rhythms that regulate our sleep cycles. People working at night under bright lights or living in light-polluted cities face a higher risk of developing diseases such as breast and prostate cancer. Here is a night sky with typical light pollution. On a good night, only the brighter stars and planets pierce the glow. This is what the night sky might look like if we could remove the light pollution. That faint band of light stretching across the sky is the Milky Way, our home galaxy. Because of light pollution, many people have never seen it. Astronomers know all too well the problems caused by lighting up the night. They need clear, dark skies to study the many fascinating objects in the universe. Light pollution simply washes out their view of the cosmos. Lighting up the night sky wastes money and fossil fuels. To keep a 100-watt light bulb turned on every night for a year takes the equivalent energy output from burning half a ton of coal. Multiplied by the billions of lights blazing up from Earth, the cost of energy we use to light up the night is colossal. While lighting is needed, there are some simple things we can do to ensure that it's neighborhood-friendly, energy-efficient, and helps preserve dark skies. We can replace light fixtures that send light up to the sky with ones that direct light down, exactly where we want it. They're called fully shielded fixtures. We can also illuminate only the places that need it. And of course, we can just turn off unnecessary lights. These are smart ways to use lighting. They offer simple solutions to problems caused by light pollution. We have a choice between wasting resources by sending light to the sky or learning to use light more responsibly. Light pollution is a problem each of us can help solve. Together, we can bring back the dark of night to planet Earth.
So I thought I would start today by giving you a bit of just a personal story of how I came to astronomy and how I sort of came to appreciate my nighttime environment. I was a physics major at the University of Montreal, a city kid, that never really cared about the stars or anything like that. And I was a volunteer teacher in Central Africa, in Gabon. This is a sign not far outside of my town. Actually, it's close to the Cameroon border, essentially showing you what life was like there. And I remember one night walking back from town. I would walk across through town. It's interesting that this is a picture taken in my town, but it's a recent picture that I stole from the internet. And you can see that in some of the neighboring villages right around Bitam, where I lived, they've actually installed solar panels to provide lighting. And sort of that was a fixture of what life was like there. I taught at a high school in a Catholic mission, and we had electricity, but most folks in town and obviously the folks in the village didn't have electricity. And the result was that the skies were incredibly dark. Here's a picture of me that I actually have in my office. That's a young me there. And I'm leading my students in a parade through the streets of downtown Bitam. And when I was in town, so this is a relatively modern day picture. And what was interesting about this town is that even though we didn't have television and limited electricity and no telephone, we had an airport that could land jumbo jets. That's the airport, that's the landing strip. And town was over here, and the mission was off the picture here, a couple of, maybe 3 kilometers away. And when I would walk back from town at night, I would actually have to cross the runway, which is fine. There was only a couple of planes a week anyway. And I remember one night literally sitting on the runway and not only appreciating the sky above me, but sort of feeling the earth below me. And I have to admit, as a Canadian kid, we went for hikes and I sort of appreciated the forest, but I never really felt the earth. And that was an important moment for me, this connection between the sky and the earth and the totality of this place that we live in. And the other thing I saw, and I have to tell you, what I saw in the night sky was really not so different than this. Now, obviously, this is a long exposure photograph, probably a 30-second exposure photograph taken with a digital camera, but this is what it was like. There would be a clearing. Very often I would go and watch the sky from the ball field at my school, because that was the place where we could see through the canopy of the trees the most. And I really could see the Milky Way this vividly. This is Central Africa. We were at 2 degrees north latitude. In most seasons, the Milky Way was basically passing directly overhead. The center of the Milky Way in the summertime was basically straight overhead. And I swear to you, I could see colors, brown colors, red colors, green colors in the Milky Way towards Sagittarius. And it changed me. And it's at that moment that I decided I would go, after I finished teaching in Gabon, that I would go on to graduate school and go into astronomy and physics. And this is the place where I learned to love the sky. And I guess what I'm trying to say is that I wouldn't have learned to love the sky if I hadn't experienced the sky. And so, getting down to the science of what we're going to talk about today, one of the way we classify how dark the sky is using something called the Bortle scale. And basically the Bortle scale runs from 1 to 9, with downtown Manhattan being a 9, and somewhere in the middle of the Sahara being a 1. And basically this is giving you an idea now of essentially what you see. Again, these are photographs that are taken all at the same exposure to give you a sense for what you can see. And believe it or not, really, in order to be able to see the Milky Way at all, you sort of have to be at a Bortle scale of 3 or better. And most of us are obviously living in an environment that is far, far worse. A statistic that the International Dark Sky Association likes to talk about is that 80% of Americans and 80% of the world's population basically live in a place where they cannot see the Milky Way. In fact, a lot of people under the age of 50 have actually never seen the Milky Way. And that's not because they couldn't have, is that, and this is something I hope I have time to talk about at the end, but it's kind of the sociology of this particular environmental issue and the sociology of environmental issues in general. I think what happens now is that because people don't experience the sky every day, they don't even think to look at the sky when they are in an environment where they could actually see the Milky Way or appreciate the stars. It has become something that they just tune out. And if you think about it, if you're walking at night or even during the day, half of your total field of view is above you. And the question is how many of us are actually taking a moment anymore to look at the clouds or to look at the atmosphere or to look at the sky at night. The International Dark Sky Association has a little page about our nighttime environment, and they talk about Vincent van Gogh, and they make a point that I'd never thought about before. Vincent painted Starry Night in Saint-Rémy, France in 1889. And obviously everywhere in the world, including Central Europe, you could see the sky at night in all of its brilliance in 1889. And now a little over 100 years later, you cannot see any of this from the town where Van Gogh painted this. And it makes you wonder whether Van Gogh would have ever been inspired to paint this painting. I think the point I'd like to drive home today is that I personally would like to see a return to be able to live in an environment where I can appreciate my nighttime environment. So this is what our region looks like from a satellite. Okay, now it turns out that this is important for research, but it's actually not very telling in terms of what light pollution is actually doing. Obviously, if you can imagine yourself living at one of those bright points, you can imagine, wow, there must be way too much light there to actually be able to see the sky. But what I want to make you appreciate in the next view graph is that when a satellite, which is at an altitude of 250 kilometers, is looking down on the Earth, they are seeing straight through the atmosphere down to the ground. When we stand on the ground and we look up, we are essentially experiencing the scattering that is occurring throughout the atmosphere. Right now, it's it's 12:25 in the afternoon. I look outside and I see the blue sky. That is sunlight. Those are photons from the sun that have been scattered by our atmosphere to the point that the blue photons and the violet photons and the green photons have essentially been scattered so many times that we can actually see bright blue light many, many degrees away from where the light is actually coming from, which is the sun. Okay, so this is a picture taken from the Nevada desert, hundreds of miles outside of Las Vegas. There are no lights within 100 miles of this location, and yet the sky is entirely dominated by light pollution. And this is because of the properties of light and the properties of scattering. So this is a graph that, I think you show even in an environmental class to help students understand scattering in the atmosphere and how that impacts the energy budget of radiation in the atmosphere when we talk about global warming and we talk about greenhouse gases. And this diagram is actually relevant also when talking about light pollution. It turns out that the atmosphere scatters light basically two ways. There's a process called Mie scattering, which is usually larger particles that are scattering light. And it turns out that Mie scattering does not depend on wavelength. It doesn't depend on the color of the light. It doesn't depend on the color of the photons that are being scattered. A lot of that yellow light that you see when you look near the horizon towards a city is Mie scattering, okay? And that's because the Mie scattering is also preferentially forward scattering. So as you're looking towards that city, you're seeing photons being scattered up here and back into your line of sight. The one that's actually really bad for astronomy and really bad for seeing stars actually is the Rayleigh scattering. That is the scattering that happens even when you're looking straight up. Basically what happens with Rayleigh scattering is Rayleigh scattering happens in all directions and it happens preferentially in the blue part of the spectrum. The other thing has to do with the way our eyes see light. It turns out that our eyes sort of turn off the color sensitive part of our vision when we're looking at night and when we're looking up into the sky. And once again, those cones in our retina are actually relatively more sensitive to blue light, which is why stars look basically white. And so that further inhibits our ability to see the night sky. Now, it's interesting, early on in this fight to try to reduce light pollution, a case was made and cases were made to municipalities and to departments of transportation all over the country and all over the world that one of the main reasons you want to switch over to LED fixtures is to save, to not waste energy. That is to save money and to reduce greenhouse gases and such. And so that was done. And that could have been potentially helpful for reducing light pollution. but it turns out that it's actually made the problem actually substantially worse. So, and what I want to share with you today is this idea that you can both help climate change and help light pollution, but you need to have the right kinds of lights in place. Let me give you an idea of what we're talking about here. So you'll notice that there are 4 photos here. The top photos on the left and on the right were taken in Milan and in Los Angeles early in the 2010s, so about 10 years ago, when they were using conventional lights. And in many cases, especially on some of the major highways, they were using what are called high pressure sodium lights. And you can actually see that in this image here. These streaks of yellow all throughout are all highways typically that had those yellow lights, those yellow high pressure sodium lights. And if you think about it, in a lot of places, we don't see those lights so much. They sort of appeared and then disappeared. And they've actually been replaced by LED fixtures that are actually much more energy efficient. And the reason, by the way, that they're energy efficient has everything to do with the electromagnetic spectrum. It has to do with the fact that these new fixtures emit nearly all of their light in the visible part of the spectrum and not so much in the infrared, where about 75% of an incandescent light bulb. So the high pressure sodium lights were put in the first place to serve energy, to conserve energy, but it turns out that the LEDs are even more efficient at doing that. But you'll notice in the lower photos, both in Milan in 2015 and in LA in 2012, after those conversions were made, there's actually more light rising up. And more importantly, that light is bluer. And if you think about the Rayleigh scattering that we were just discussing, that means that now that those places are not only experiencing increased light levels overall, they're seeing much more blue light, which is going to scatter even more effectively. The International Dark Sky Association published a report back in 2010, actually, around the time that we're talking about the health effects on humans. And again, these are a bunch of astrophysicists, right? So we think like physicists. We don't really know much about biology. We don't know much about human health, but we do know something about radiation. And so one of the things that's been done is that there have been some neurological and biological studies on human response regarding our circadian rhythm to light. And it turns out that our circadian rhythms are actually regulated mostly by our sensitivity to blue light. Again, this, I think, comes back to what we were talking about earlier in the fact that in terms of our photosensitivity, we actually have a lot of photosensitivity in low light situations to bluer light. And so as a result, there was a realization a little while ago that typical LED lights are actually bad for our circadian rhythms, right? For disrupting our circadian rhythms. And so you'll notice that these spectra here up in this corner, this is the kind of thing I show in my astronomy class, but coming from nebulae and stars, obviously, not from light fixtures. But these different kinds of light fixtures actually have very different spectra. If you actually break their light up in a prism and look at the distribution of light, you'll see that high pressure sodium versus low pressure sodium versus incandescent have a very different light distribution. And it turns out that sodium lamps, especially low pressure sodium lamps, in terms of what they would do to our circadian rhythms and what they would do in terms of light pollution, are actually very good. And unfortunately, light emitting diodes are actually not very good, generally speaking, especially ones that are set to a high temperature. If you've ever been to Home Depot and you've looked at some of these light fixtures, you'll see that you can actually regulate them. And typically they have a regulation from about 3000 Kelvin, right, which is relatively cool, all the way up to maybe 4500 or 5000 Kelvin, which gives you that white blue light. And as I'll show you, that's unfortunately the setting a lot of municipalities and a lot of individuals have chosen. The bottom line is that this blue light is not only bad for our health, but it's very bad for light pollution. Looked at another way, here's a typical LED here, and you'll notice all the way on the right side of this panel, this is an LED which is set at a low temperature. Nonetheless, that low temperature LED and the temperature of the LED is dictated by the peak. You know, do you see that peak in the orange-red part of the spectrum at about 600 or 620 nanometers? That's what dictates the temperature, but you'll also notice that there's this blue bump, okay? The two fixtures on the right, on the left, I mean, the narrow band or direct emission amber LED and the phosphor converted amber LED have light distributions that are actually much better for human health and are actually much better in terms of what they do with regard to light pollution. So the upshot of all this, right, is that if we want to do what's best in terms of outdoor lighting, we have to reduce intensity, we have to reduce temperature, but we also have to use the right kind of light fixtures, and those light fixtures need to be fully shielded so that they're sending light down to the ground and not up to the sky. This is not only important for light pollution and human health, but it's also important in terms of reducing another risk factor that's actually gone up over the years, which is glare. It turns out that glare from these lights actually is a driving hazard. And it's not only a hazard for drivers, but it's a hazard for pedestrians as well. What's happening now with these very bright LED fixtures that are unshielded, basically you're driving down the road and those lights are coming into your eyes. And so this is turning out to be sort of an issue. So here's a fairly typical situation here. You actually have a town that has removed old high pressure sodium fixtures and installed new LED fixtures. Now they did a lot of things right, in my opinion. They're downward facing, they use less energy, the road is far better illuminated than it was before. And because they're high and downward facing, drivers are not really subject to glare. From an illumination standpoint, it's awesome. From a light pollution standpoint, it's actually worse than what was there before. And so the only way to really fix that is to reduce the amount of light and also to change the color of that light. So how about closer to home? So this is where we begin. Okay, so I actually got involved in this project in January of this year. So it's only been a few months now. And I happened to teach the remote sensing course at Westchester. And so I was teaching the remote sensing course last spring. And I sort of asked myself, so how bad is it around here? So a couple of things here. There's a tool that actually just came out, I think, in March of this year. We were literally in the middle of our remote sensing class when this tool became available. It's called Google Earth Engine. If any of you are kind of into mapping or into geographic information systems in any way, this is a very interesting tool that allows you fairly easily to access and filter and download remote sensing data from real remote sensing satellites, and then to overlay them on all kinds of maps. And so I did that. Now, the first thing I want you to notice about these images is that this was actually relatively easy to obtain and to produce this image. It really only took a couple of minutes to do this in Google Earth Engine. But you might be asking yourself, wait, what am I looking at here? Okay, so we're actually looking at Philadelphia here. We can see Philadelphia proper here. We see Wilmington down here. I think this is King of Prussia Mall up here. 422 is running here. This must be 276 up here. This has got to be 95 down here. This has got to be where I'm pointing right now. This little light between Wilmington and King of Prussia is not Westchester, actually. I believe it's the malls, like Concord Mall outside of Wilmington. You know, and what's nice now in Google Earth is that we can just do a quick overlay, and sure enough, there we are right on the Delaware-Pennsylvania border, and that's that big mall there. And here we are in Westchester over here. So these data come from two satellites that are basically orbiting the Earth every day, taking data. And what they do is that they generally combine data from cloudless nights. It's actually observing all day and all night. And the data are gathered and cleaned. They average all the nights that had clear data for that month. And you can go basically look at any month and you can actually see the timeline and the availability of all the data up in this window here. And what I want to point out actually is that the first data set that I've got here is April of 2012. The next data set is from April of 2021. Okay, the problem is getting worse. I want to point out that these aren't ordinary photographs. These are calibrated. These are calibrated photographs, and we can see actually fairly easily that not only is the problem getting worse in downtown Philadelphia, but it's getting worse everywhere. And this is one from January of 2022, worse still. So how are we doing in Westchester? Well, there's Westchester. I want to point something out here. Weather satellites are great for many, many things, but they are notoriously bad when it comes to spatial resolution, meaning that there are satellites that have much, much better spatial resolution that can show you a lot more detail. Weather satellites are not those satellites. And so this instrument called the VIIRS instrument is on a weather satellite. And so these are half-mile pixels. These are 750 meter pixels, 0.75 kilometers. So they're big fat pixels. So we don't really have that much data. It's not like I can tell you that this business or that business, or you know, I can't tell you exactly where that light pollution is coming from, plus or minus half a mile. So there's Westchester right in the center of the image. And you might think to yourself, well, I guess we have a little work to do. We need to go talk to the borough. I'm going to overlay a map now. I just want to point out that downtown Westchester is over here. And there is some light pollution in downtown Westchester, but that's not where those bright pixels are coming from. They're coming about a mile away, mile and a half away. And I hate, you know, I'm not trying to roll Scott Honda under the bus, but that's Scott Honda right there. So if you've ever been down in that part of town, okay, and I happen to live in that part of town, there's a big ball field next to the county building. And the lights are on sometimes all night there. There's a big industry out on Neal Street. There are a couple of big trucking companies right on Neal Street, and there are car dealerships all along there, not just the Scott Honda. There's a Kia dealership higher up on Westtown Road, and then there are other dealerships lower down closer to 202. These are the culprits. This culprit over here is the airport. Now, you can make a case that maybe the airports need to have lights on, but I just want to point out that there's actually a bigger problem from shopping malls and car dealerships than we have from the airport and the hospital. So one of the things that some of our members have started doing, this is courtesy of Suzanne Webster. She lives in Downingtown and has been quietly, well, not quietly. She's not quiet at all, actually, but she has been whistling in the wind a little bit in Downingtown for many years, trying to solve some of these very obvious light pollution situations. These are literally photos that she takes as she's going around town. She's been working hard with the mayor of Downingtown and their borough council to try to reduce these problems. But this is the kind of data that we're taking. We're taking ground-based, ground-level photography of light pollution, of dark regions and of light pollution sort of throughout the area. But as you'll see, we intend to do more. So this view graph says, what are we doing to reduce light pollution? And I have an asterisk there because there is a we. I don't just mean we in the sort of abstract sense. I mean we in the very specific sense that the Westchester Green Team, like I said, we've put together a dark sky committee. We have about 20, 25 people that are active members of this. And like I said, we're really just getting going this year. So what do we want to do in terms of research? So this is the sustainability research and practice seminar. So this is both research and practice. It turns out that there's a lot that we can do. These images are courtesy of Diane Turnshek, who has really been kind of my guru, personally speaking, sort of as I've been stepping into this new role. And one of the things that they have done in Pittsburgh that they used to actually convince the city of Pittsburgh and the state of Pennsylvania that there was an actual problem is to actually collect data. And so you need numerical quantitative data. And so what we did about a month and a half ago, is we purchased one of these sky quality meters. And basically we're looking for an intern who's going to be able to work with me and the committee to start going around. We're going to start in the borough of Westchester, and we're going to fan out to East Goshen, West Goshen, some of the surrounding municipalities, and eventually fan up to O2, possibly, hopefully, maybe as far as King of Prussia Mall, with the goal eventually of gathering data for the entire county. And basically these sky quality meters allow us to take quantitative measurements of the darkness of the sky, not only near the horizon, but directly straight up. And then what we can do is we can geo-reference all of those results. We can put that on Google Earth or in Google Maps, and we can essentially create a database of readings that we can obtain this way. The second thing, which is super useful, and this I have to thank the Joby Hilliker and Martin Helmke and the faculty members in the Earth and Space Science Department, is that they like to play with drones. I don't know how much research they're actually doing. Sorry, that's a jab at you, Joby. They're doing research, sorry. But the point is that I want to use the drones now too, because the drones are actually excellent for obtaining relatively well-calibrated data from the ground. As I told you earlier, one of the problems with the satellite data is that it is very poor resolution. What the drones can do, we can legally go up to 400 feet. These cameras are wide field enough that you can take images exactly like this. And that is extremely helpful for calibrating with the satellite data, because then the field of view of the drone is approximately 1 pixel on the satellite. And secondly, it's good for identifying hotspots and finding out where we really need to work in order to reduce light pollution. So this approach, I'm hoping, and this is necessarily going to be a long-term research effort, because it's going to take a long time, for a human being to go and to make these measurements everywhere, for us to go out, fly the drones. My guess is we'll be able to take maybe 5 or 10 drone images a night, but weather's a problem. So this may take a while. So I want to be sensitive to time. I want to allow folks online and in the room to ask questions that they want, but I want to share some thoughts with you. And this is where Mark the scientist becomes kind of Mark the opinionated scientist, and really more the opinionated citizen. Light pollution is a problem that has been progressively getting worse, with ups and downs, as I mentioned earlier. And like many environmental problems, it's daunting because it looks like the problems are getting worse rather than getting better. And the question is why should you care? Okay, this is obviously not the most pressing problem facing the environmental movement. It's not the most pressing problem facing the planet. So why do I care? Well, the answer is I care because I love the nighttime environment. I remember going to telescopes for the first time as a graduate student and as a postdoc, and doing research and being in a place where I could appreciate the nighttime environment, being on Mauna Kea in Hawaii at night above the inversion and seeing the sky and being able to see hundreds of miles around me in the Pacific and seeing that nighttime environment. Those were meaningful experiences to me that meant a lot to me, and I think they would mean a lot to my children, and I think they would mean a lot to people in general. Now, it's interesting because light pollution is a relatively solvable problem. The damage that's been done to the environment has been mostly in the form of wasted resources, and obviously that impact of burning fossil fuels and its impact on the climate. But the light pollution itself, it's light, it's gone. You turn off the light, you turn off the lights, the light pollution is gone. You can literally rediscover your nighttime environment relatively simply by simply cleaning up your local environment. Unfortunately, based on what I showed you about the scattering, that local environment isn't just a few miles, it's maybe a 100-mile radius circle or something before you really start to have an impact, but it is a solvable problem. So then the question is why isn't the problem getting better? Meaning that if we have the means to make the problem better, we have technology now and fixtures now that are everything that we need, why isn't the problem getting better? And I actually think it's a problem of exposure. I don't think we can care about the environment until we've experienced the environment. I don't think we can care about nature until we've experienced it. So if you've never left the city and you've never taken a hike out in the wilderness, you have no motivation to save the wilderness. What I would say is that if you've never experienced a true nighttime environment, and I don't mean just the sights, but the sounds as well, the crickets, the quiet, the noise pollution is deafening. When the pandemic hit, I stopped driving my car to work and I walk home every night. And so when I teach a late class, I'm walking home at night. The noise is deafening as I walk home down Neal Street with all the trucks. And this is at 8 o'clock, 9 o'clock at night, and I can't hear myself think. This constant din of noise pollution and visual pollution, I think, is literally making us now unable to even imagine what the world was like before. And the funny thing is, it's only been 100 years, and yet we've actually become disconnected from our environment. And what's interesting is, from a biological standpoint, we have not adapted to our new reality. So as a biological species, we're still needing the environment that evolved us to the point that we are today. But psychologically, we live in a world and in a society that is completely not only disconnected from the environment, but disconnecting from ourselves. I'm talking about social media. I'm talking about this connection now that we have to our screen in front of us, even as opposed to the connection that we have to people that are 20 feet away from us. So I don't know. I think this is my first year as an environmentalist. I probably feel the way most of you have felt your entire lives, that this is a battle that I don't know how to win, but I feel like it's worth fighting for. So that's my message. Yes, we're losing the dark, but maybe we should try to win back the night. All right, I think I'm right on time.
Okay, thank you.
All right.
See, did you log off of the?
No, I don't know what happened there, but
Let's see.
oh no, sorry. All right, so
Okay.
I'm just going to kill that.
If you have a few minutes and could answer some questions.
Yep.
Perhaps we want to offer to the Zoom audience first. I suspect Walt has a question.
Oh, is Walt one of those guys that asks a question all the time?
I often ask a question, but when I don't ask a question, I feel bad because Brad always says, Walt has a question. And then Walt,
Uh-oh.
do I have a question?
It sounds like Walt does not have a question.
Well, I have appreciation. I really love that talk. I loved your message. Loved the way you put it together. I loved your personal story behind it. And this is exciting. We in media may be in touch.
Yeah, it's fun. And there might be some papers that could come out of this. There are actually journals that are dedicated to this stuff. So who
Wow.
knew?
Yeah. Well, yeah, we went through LED conversion of our streetlights in media, and we wanted to make sure that they were downward facing.
Yeah, one thing I didn't talk about is this misconception that somehow these lights, especially the brighter lights, are making people safer. And there's countless studies that have shown that crime and personal safety and traffic accidents are simply not related to these things. Texting is way worse than no lights.
Yeah, I wish I had heard this talk before we made the conversion, just to make sure that we're in fact doing it right.
Yeah, but it's okay. There's still time. Those fixtures will break. So
Oh, there you go.
and your borough will be, strapped for money, and so that's the good news.
Mark, for questions
Yes.
in the audience, would you repeat them so that?
Absolutely. Go.
Yeah, well, first of all, thank you. Really fascinating information. I feel like I've wasn't as familiar with, so I appreciate that.
All right, thank you.
Just started to touch on my question is largely around, thinking about the advocacy for the night sky. I do think that what you run into is safety concerns fundamentally.
Oh, sure.
It's like, we need to think about it from a societal level. We have been conditioned to be afraid of the dark.
Absolutely.
There is an inherent fear in darkness, unfortunately. And you could get into like why that is. We're not going to do that right now, but like I do wonder when you're advocating for this, how much pushback are you going to get from Scott Honda that says, I want to protect my inventory. I don't want my cars to get broken into because there's no light. There may be crime, even though I understand that the research is there. It's like, how do you
Absolutely.
how do you design the
Absolutely.
research in a way to take the fear away?
I mean, we see those arguments made when we're talking about gun control. We see those arguments made. There's the feeling of safety, and then there's actual safety. And the research is clear. I'm not going to talk about gun control. The research is clear that your actual safety is not improved. Actual crime, actual theft is not this. I mean, it makes sense, but one of the things that we fight against as scientists is this idea of explaining things through logical argument. So somebody makes the statement, well, listen, lights keep you safer, right? I mean, it sounds sensible, right? It makes sense, right? It just happens not really to be true. And so how do you fight that? And I think the only way, and this is a page that we can take from the environmental movement. One of the things that's had an amazing amount of impact is actually what we do here at the university, is that we are training teachers. And yes, we are brainwashing teachers. Make no mistake. Students are leaving this university more environmentally conscious than they were when they arrived. And those teachers are having an impact. I have 3 kids, 4, 6, and 9, that are in preschool or early grades right now. And their teachers are teaching this stuff in class. We have a generation, 2 generations of children now that are growing up understanding that climate change is real and that the environment is something worth saving. And so maybe what this means is that we continue with the outreach and the education, and we continue, because the advocacy piece is going to be the hardest piece, actually, because look, let's face it, our legislators are mostly, older white guys, that have been conditioned and living in a world where these things mattered. And it's going to be a while before we can convince people in general, especially the people at the top, because unfortunately, very often, they're not even voicing their own concerns, but the concerns of what they think their constituents are concerned about. And so a few loud voices can literally drown out. And again, the plastic bag ban really taught me something. It turned out that the majority of residents were in favor of the ban. And despite a few loud voices that were against it, it went ahead and it's more or less working. And the point is that this kind of advocacy and this kind of legislation can work. But then the other advocacy piece that was up there on the view graph was this idea of voluntary changes, talking to people, talking to business owners, talking to the owner of Scott Honda and saying, look at this. We don't have any legislation on the books, but is this something that you would consider doing on your own? Yeah, so thank you so much. Is there a question from the audience? There's a chat. Thanks again. Yes, you're welcome. That's Walt. Yes, thank you, Walt. Cheryl. So Cheryl has a question. She's saying, did Mark talk about dark sky certification? I did not. I edited that out. So yes, it turns out that I think this week the International Dark Skies Association just certified their 100th dark sky site. Pittsburgh is one of the few dark sky cities, meaning dark sky city of its size. Places like Flagstaff and Tucson were sort of early adopters in Arizona, where actually the IDA is headquartered. That again, we've made some movement. Senator Comita did have a week set aside during Earth Week or right after Earth Week dedicated to dark skies in Pennsylvania. There was some legislation put forth years ago that never passed. So the next step would be to start working towards that certification, but the hoops that you have to jump through for that certification are non-zero. And so that means that we have conversations with the borough, with borough council, with the mayor, with Lillian, to try to make these things happen. It means talking to the neighboring townships, West Goshen, East Bradford, everyone, to see if we can start to move things out. And this may be the wrong approach, but the approach we're taking right now is we're going to start in the middle and just work our way out. And so, is this something that the county would be willing to adopt? Is this something that Marianne and Josh would be willing to support? I don't know. We'll see. Thanks, Cheryl.
We're almost at 1 o'clock, so we will have to
And
end, but thank you very much.
thank you for inviting me. Thank you.
Fascinating presentation.
All right, see you all later.